Hello and good morning. I welcome you to this video lecture on Big Data Analytics. In today's lecture, we are going to discuss about the historical preview of Big Data Analytics, about the Apache Software Foundation, about Hadoop and its core components, its ecosystem projects, its commercial landscape, and typical Hadoop use cases like data warehouse offload, event processing, and advanced analytics. So let's begin with today's lecture. In the year 2002, Google faced the problem of number one, storing huge files automatically on its servers. And to solve this problem, Google wrote the white paper known as Google DFS. Duck Cutting, a search framework developer, was also working on distributed file system. So this Yahoo hired Duck Cutting in 2002, 2003, and Duck Cutting took 2 years to fully implement this distributed file system, and he named it Hadoop. So Yahoo implemented Hadoop as a framework in its full-fledged production environment, and later Yahoo donated Hadoop framework to Apache, and it became a full-fledged project on Apache. Now, Google solved this problem of saving of data. The next problem was to perform analytics on it. So Google published another white paper known as Google MapReduce algorithm, and Duck Cutting and Yahoo implemented this into its own solution as a full-fledged production environment and donated it to Apache as a full-fledged project. Now, the set of storage and processing methodologies commonly known as big data. So big data has two things which needs to be taken care of. Number one is to store and number one is to process, right? So it emerged from, the search engine providers in the early 2000s, principally Google and Yahoo. Now, these search engine providers were the first group of users faced with internet scale problems, like mainly how to process and store indexes of all the documents in the internet universe. For this, Google released the white papers on Google File System and the MapReduce simplified data processing on large clusters. And Duck Cutting was instrumental in creating the Hadoop software to take care of these problems. The Google white papers obviously inspired Duck Cutting to, finish the work that he started on the Nudge project and incorporate the storage and the processing principles outlined in these white papers. The resultant product is what is known today as Hadoop. Now, Hadoop was born in 2006 as an open source project under the Apache Software Foundation licensing scheme. So before we discuss any further on Hadoop, it's worthwhile to discuss about this Apache Software Foundation. So I'll be discussing about Apache Software Foundation, and this Hadoop was, it came into existence because of the following, things that were prevalent at that time. The rapid expansion of the e-commerce, like buying and selling on the internet, the birth and rapid growth of the mobile internet, okay, and blogs and the user-driven web content and the social media content. And these innovations cumulatively led to what is known as the data deluge, the flooding of data. And this accelerated the expansion of the big data movement and led to the emergence of other related projects such as Spark and NoSQL platforms. So since we were dealing with unstructured data, so the NoSQL platforms, NoSQL databases came into existence, and other data processing platforms, projects like Spark also came into existence. So let's now discuss about this Apache Software Foundation. It is a non-profit organization founded in 1999 to provide an open source software structure. So by open source means for which we don't pay any licensing fee. Anybody and everybody is free to use this and to further contribute to this software projects. Now it is based upon the concept of meritocracy, meaning projects are governed by merit. And people, they contribute, they use these softwares and they contribute, they suggest improvements in this. And this is typically, these people are active on mailing lists and support forums. and they provide suggestions, criticism, and patches to address defects. So, if a software is provided to people free of cost, always there is going to be bugs in that. So, people are, suggesting, criticizing, and providing patches to address the defects that are there in a software. Now, let's discuss about Hadoop. So, Hadoop is a data storage and processing platform based upon the central concept, that is data locality, right? By data locality, we mean that we bring the computation to the data rather than the typical pattern of requesting data from its location. And also, Hadoop enables large data sets to be processed on the nodes of a cluster using a shared nothing approach. So, cluster is simply, a collection of hundreds and thousands of systems connected to a mainframe, and we'll be discussing more about clusters in my later videos. Right now, we can discuss that Hadoop is schemaless with respect to its write operations. So it is known as schema on read. That means you don't need any structural data for Hadoop to analyze. Okay, whenever the data comes there, the schema on read system Hadoop will take care of the processing and the storage of data. Then there are schema on read systems and schema on write systems. When we talk of schema on read systems, Hadoop is one such system. And when we discuss of schema on write system, then whatever we have studied in the various relational database management softwares like Oracle, SQL Server, MySQL, they come under the category of schema on write systems. And similarly, the NoSQL platforms, NoSQL means not only SQL, these platforms such as Apache HBase or Cassandra, they are classified as schema on read system. That means they don't require any structure for the processing of data. Because the schema is not interpreted during write operations to Hadoop, so there are no indexes, statistics, or other constructs typically employed by database systems to optimize query operations. And Hadoop is designed to find needles in haystacks, and that is based on the concept of data locality and shared nothing approach. Now let's discuss about the Hadoop core components. So Hadoop has mainly two core components, the Hadoop distributed file system known as HDFS and YARN, which stands for yet another resource negotiator. So HDFS is Hadoop's storage subsystem, whereas YARN can be thought of Hadoop's process scheduling subsystem. So Hadoop is HDFS is for storage of data, for storage, and YARN is for processing of data. These are the two core components of Hadoop. And each of these components is independent of one another and can operate in its own cluster. So a cluster is a collection of systems, as I told you, that work together to perform functions such as computational or processing functions. So HDFS cluster and a YARN cluster can operate independently. So these are the two Hadoop core components, HDFS and YARN. So they can work together also, and they can operate independently, right? So when they are co-located with one another, the combination of both systems is considered to be a Hadoop cluster. Okay. So individual servers within clusters are referred to as nodes. So these things would be more clear when I actually discuss what a Hadoop cluster is and how it operates. Now coming to Hadoop ecosystem projects, any other projects that interact or integrate with Hadoop in some way. Okay, so Hadoop is one project. Any other project that interacts or integrates with Hadoop in some way, for instance, data ingestion projects such as Flume or Scoop, or data analysis tools such as Pig or Hive, these are known as Hadoop ecosystem projects. So in many ways, you could consider Spark also as an ecosystem project, but this is disputable because Spark does not require Hadoop to run. So you can see here the Hadoop ecosystem projects. The data analysis projects, they are the Spark, Hive, and Pig. And the data ingestion projects are the Flume and the Scoop. Then we have the NoSQL databases, Apache HBase and Apache Accumulo. And for security, we have Knox and Sentry. These are the Hadoop ecosystem projects. We are not supposed to discuss these projects in detail, although we would be discussing this Apache Pig in full detail for analysis of huge data sets. Now, the commercial Hadoop landscape. Let's now understand what is the commercial angle to Hadoop. Although Hadoop is an open source project, as we discussed earlier, there are many commercial vendors who supply commercial distributions, support, management, utilities, and more. Okay, so we see that Hadoop is an open source project which anybody can use free of cost, but there is also a commercial angle to it. So the first commercial vendor was Cloudera, which was formed by engineers from Google, Yahoo, and Facebook. Cloudera subsequently released the first commercial distribution of Hadoop called the Cloudera distribution of Hadoop. Now, Cloudera, Hortonworks, and MapR are referred to as pure play Hadoop vendors as their business models are founded upon Hadoop. So there are two types of Hadoop vendors, the pure play Hadoop vendors and the open data platform initiative Hadoop vendors, right? So these are the other vendors such as IBM, Pivotal, and Teradata, which follow their own distribution, and Hadoop is not necessarily their core business. Okay, so they come under this open database, open data platform initiative ODPI, which was founded in late 2014. So now you can view on screen the pure play Hadoop vendors. Like these are the vendors whose commercial business model is entirely based on Hadoop. So there is Hortonworks, there is Cloudera, and there is MapR. And the members whose core business model is not Hadoop, but they use Hadoop in certain capacity. These are known as the open data ODPI members. And we have this Pivotal, Splunk, EMC, and so many other companies are there which come under this ODPI category. Now let's discuss about the typical Hadoop use cases, like where we are going to use Hadoop. So the first one would be the data warehouse, the ETL offload process, the event and complex event processing, and data mining and machine learning that would come under advanced analytics. So let's discuss these Hadoop use cases one by one. The first one is the data warehouse offload. This is the most common use for Hadoop, that is the data warehouse offload. It is the process of using Hadoop for long-term storage, number one, as well as for performing pre-integration ETL routines. So a data warehouse offload is like where you can keep a huge amount of data which can be processed, later on. And advantages would be lower storage cost and lower processing cost because of distributing processing capabilities of Hadoop. Since Hadoop, processes data by distribution of data, so the processing and the storage costs are quite low. And higher cost is incurred in case of specialized uh, multi-parallel processing platforms such as Teradata or Oracle Exadata. So if you're using MPP platforms, multi-parallel processing platforms such as Teradata or Oracle Exadata, a higher cost would be incurred. Whereas in case of Hadoop, lower storage as well as lower processing cost is there. The second thing is event processing. It usually involves ingestion and processing of streaming data sources such as sensor data, message data, or log data. So like the data that is being generated from various sources, we can just, process this data. So this event processing would be collecting and processing data from thousands of endpoints, including temperature sensors, RFID, NFC scanners, CCTV cameras, signaling systems, and more. And Hadoop provides a low-cost storage and a computational platform to mine volumes of messages to identify patterns or peculiarities, right? Then in advanced analytics, it is a process of identifying patterns in data and building mathematical models to represent these patterns. So first we pick up the data, process it, and then we build a model to predict the outcome from this data, like what the future data would be providing to us. And advanced analytics is used for predictive modeling rather than descriptive analytics. Okay. Specific applications include customer churn or attrition prediction. So basically some prediction based on some results that we have achieved in present, and propensity modeling, fraud detection, image or facial recognition, and many more. And this advanced analytics encompasses the specific disciplines of data mining, uh, such as predictive modeling and machine learning. And Hadoop enables these recursive approaches at a huge scale. So that is all for today's video lecture. In my next video lecture, I'll be discussing more about Hadoop, the Hadoop cluster, and how the cluster operates, and what are the typical configurations for the Hadoop cluster. So till then, I'll stop this video here, and in my next video, I'll be discussing more on this. Thank you so very much for today's session.